Okay, this is part 5. I'm going through the last two questions of this January 2021 Edexcel IGCSE physics paper. So it's also the paper used for double award science. So if you watched the previous videos, thank you for watching. Make sure you like, share the video with your friends, and make sure you subscribe because more videos will be coming your way in helping you prepare for your mocks. So this question is a 6-mark question. Or it's got a 6-mark section in it where you've got to explain things clearly. It's about heat, okay? So the photograph shows a large hurdle on an athletics track. You can see it's painted 2 colors, black and white, and the question is about that. The bar of the hurdle is made of wood and is painted black and white. So you can immediately think that the question is going to be about radiation, because remember, black and white is about absorption of thermal energy. Okay, so the temperature, it says the temperature of the hurdle increases when the sun shines on it. Yeah, why does the temperature increase? Because obviously the rays of sunshine, like infrared rays, are absorbed by any material, and to a greater or lesser extent. And you know already just from common sense that white objects will reflect more, black objects will absorb more. Okay, so it says explain which part of the bar reaches the highest temperature. Yeah, so explain why, in other words, the black part will reach a higher temperature. That's what they want you to do. So that's a 2-mark question. Well, the black part will reach the higher temperature. Yeah, that's because black is a better absorber of what? Black is a better absorber of radiation. Okay, so this kind of links electromagnetic rays with the topic on energy, where thermal energy is one of the forms of energy, or one of the forms of thermal energy transfer as well. Okay, so the energy store thermally in the black pigment will be higher, and the atoms under the black area will start vibrating more vigorously than under the white paint. Okay, so it's about energy stores and about thermal energy transfer. Okay, heat is thermal energy transfer, heating. It then says the air near the bar receives energy by heating. Yes, where does it receive it from? Well, it receives it from the bar. Yeah. Explain how then a convection current is formed. Yeah, obviously in the air near the bar. So the temperature of air near the bar will increase because the air is in thermal contact. Yeah, basically the air will collide, the particles in the air will collide with the bar, and when they hit the bar, especially the black part, they will gain kinetic energy. So particles of air, or molecules, yeah, in the air will gain kinetic energy as a result of this contact, thermal contact. So the air particles, if you like, will move faster and further apart. And in the process of moving further apart, yeah, the air expands. Because if they're moving further apart, they're taking up more volume, so they are, in fact, the air volume will increase. Air is said to expand. And by doing so, by spreading out more, the density of the expanded air will be less than before, so it will decrease. Okay? And because it's now less dense, the less dense heated air, in other words, it will float on colder air, and therefore it will rise. Yeah? Less dense air will rise. Okay? And the cooler air, which hasn't made contact with the bar, so it hasn't been heated yet, will replace the hot air which rises, yeah? And this cycle repeats itself, this process repeats itself, causing a convection current. Yeah? So basically, if we go back to the diagram, hot air, the air above the black area will become less dense and rise. Yes? And then obviously cooler air will take its place, and this will continue to take place, that the hot air rises, colder air will sink, and that's how heating occurs. And this happens, for example, on the beach on a hot day, the sand will get hotter, and the sand will heat the air above it more than the air above the sea, and that will cause the air above the sand to rise by becoming less dense, and colder air from the sea will take its place, and you've got a little breeze coming in from the sea, therefore. Okay, that's called a sea breeze. And this is what a convection current is. So these questions are quite tricky in terms of being able to put your thoughts down clearly in the exam. Now remember, I always tell my students, the way you get the marks, and here the 6-mark question is in fact split into 2 and 4, yeah? Any of these 4 points that I've made here will get you the marks. So there's the clarity of your communication, there's depth in your answers, that you've used the correct terminology scientifically, and there's detail. Now if you miss out any of the detail, you're not going to get the marks, okay? Not going to get all the marks at least. So you've got to practice doing these questions. You've got to practice doing as many past exam papers as possible. And here, I think this is the final question in the exam, and a student uses a bottle and the stopper to find the density of an unknown liquid, okay? So the stopper that they've shown you, the stopper, it fits tightly into the bottle, yeah? And it has a small diameter hole through it, as you can see, yeah? So there's a small hole, as you can see, in the stopper. And presumably the bottle will have a specific volume, okay? And here is the student's method. So this is about scientific skills and practical investigations. So they want you to think about how you're going to answer this question. The student's method: use a balance to find the mass of the. Okay, so what are they trying to do? They're trying to find. The aim is to find the density. They want you to find the density of an unknown liquid. Okay, so obviously they're going to put the unknown liquid inside here. Yeah, so that's where the volume of the liquid will go. So first of all, the student's method is use a balance to find the mass of the bottle and stopper, yeah, when it's empty. That'll be the empty bottle mass. You need that to determine how much it will weigh or how much mass it will have when you filled it with a liquid. So then you completely fill the bottle with water in this case, and then you insert the stopper and dry the outside of the bottle, yeah? So that in case you spilt any, obviously you want it to be the volume of the water inside the bottle. Then you use the balance to find the mass of the bottle with the liquid inside, yes? So you found the empty bottle before, yeah? And then you're going to use the same method to find the full bottle mass. So you've got the empty bottle and the full bottle mass. And here are the results. So the student's results: the mass of the empty bottle, yeah? The mass of the empty bottle was 63.4 grams. And the mass of the full bottle, 112.9 grams. So the difference will be the mass of the liquid. In this case, is water. Okay, so use the student's results to determine the volume of the water and give your answer to 3 significant figures. That's all they want. And they've given you what the density of water is. Just under 1 gram per centimeter cubed, the density of the water. Okay? So once you know the density of the water and you know the mass of the water, and you know that you can then work out the volume. Okay? So in other words, you're going to use the density equation, and the density of the water is the mass of the water divided by the volume of the water. In this case, we want to work out the unknown, which is the volume of the water. And the volume of the water will be the difference in the 2 values of mass here. You put them on the top, yeah, to work out the mass of the water. Yeah, you need to take one away from the other, and then divide it by the density, which is provided in the question as 0.998. Yeah, so given it to 3 significant figures, and then you put the values in and you get 49.6 grams per centimeter cubed, or centimeters cubed I should say. Centimeters cubed, you're working out the volume, so it'll be centimeters cubed to 3 significant figures. Yeah, your calculator accurately will give you 49.599, but they want to show you that you need to show them that you can round it up to the amount shown, which is 3 significant figures. And that's how you do the first part of this question. It then says the student empties the bottle and then dries it again. So why is he drying it? Because we don't want any extra mass on it. Yeah. So this is making sure that he has reliable data. He refills the bottle with an unknown liquid this time. Okay. And he measures the mass of the full bottle, and the stop at this time was 143.8. Now we know from part A that the mass of the empty bottle was 63.4. So now you can work out the mass of the unknown liquid as being 80.4 grams. Now this time they want you to calculate the density of the unknown liquid. Okay, and then using the same equation, density is mass over volume. This time you put in the mass there, the volume from part A that you worked out, yeah? And you can work out there's 1.62 grams per centimeters cubed. Again, should really give it the answer to 3 significant figures. Yeah, because that's what we did last time. Well, I hope that makes sense. And then it says another student uses a measuring cylinder to find the volume of the unknown liquid, which is quite a reasonable method that you probably used in a lab before. Now you've got to discuss, that means you say both sides of the story, the advantages and disadvantages of each method. So the method that they showed you in this question, and then another student using the measuring cylinder. Yeah, well, the measuring cylinder is easier. Yeah, the measuring cylinder is easier or quicker to use to find the volume. But it may not be as accurate, yeah? So it's obviously compared to the method above. So when you're discussing things, make sure you are clear that you know that you're discussing the comparison of the 2 methods. But the measuring cylinder can only measure volume to the nearest millimeter or the nearest centimeter cubed. Yeah? Whereas we got the volume to more accurate, I think 0.1 of a centimeter cubed. So you then need to clarify the fact that you could do it more accurately, whereas the bottle method that was given gives the volume to 0.1 centimeters cubed. That's 1 extra decimal place. Yeah, so it's 10 times more accurate in terms of, or more precise in terms of the volume. So the bottle measures the density more precisely because it measures the volume more precisely. Now, we'll have a look at them in a minute at the mark scheme for alternative marking points, because these are not the only ways you can describe it. So for example, you could talk about human error, you could talk about parallax error, problems with measuring the measuring cylinder accurately, getting eye level, which you should always do, yeah. And here is, I've made a note to say, you don't need to dry the measuring cylinder, yes. So there is, if the student hadn't dried the bottle, then he would have got an inaccurate mass. So this is another alternative marking point for this final question in this 110 mark paper 1, yes, 110 mark paper 1 that you just completed. So let's have a look at the mark scheme for the final question to see if we've missed anything. Yeah, so here we're looking at the final section. Measuring cylinder can read volume to nearest centimeter cube. So the first one we've done, yes. Second one, measuring cylinder is easier or quicker to use. Marking point 2, measuring cylinder does not need to be dried, yes. Measuring cylinder value could be incorrect due to parallax errors or the meniscus, that it makes it curved. So you're always meant to measure to the bottom of the meniscus. Remember, in the measuring cylinder, when you have a liquid, it usually dips, yeah. The meniscus I'm trying to draw in there is not a straight line, yeah. So that could make sure that you're always looking at it from the eye level, yes. When you're that's meant to be an eye, by the way. So the bottle gives the measuring cylinder to the nearest decimal place. So therefore the bottle method allows density to be more precisely determined. Yeah, so we didn't miss anything really. I hope you found that useful. We've now completed the January 2021 exam, and make sure you like it, share it with your friends, subscribe for the next video. I also gave my students the November 2023, so it's like just a year old, that paper, and it's already, for paper 1, it's already up in the same playlist in the YouTube channel. So have a look at the playlist for the exam, GCSE exam papers. There are many playlists, so be careful, because the channel is focused largely on A-level physics as well. So you need to make sure you go and have a look at the playlist. So you can also do the November 23 exam. And I am planning to do the paper 2 because a lot of students are asking for the paper 2 from the November 23 exam. So there are other exams that you can have a look at if you go to the playlist. So thanks for watching. Hope you find these videos useful. Please leave a comment if you got any questions. And as I said before, show your support and appreciation by liking each video you watch if it helps you a bit in your revision. It really helps with the YouTube algorithms. Okay, hopefully see you in the next video. Bye for now. See you in the next video.